Hi everyone, it is the recording for Tuesday, April 7th. Today's recording is going to be short. The lesson's actually really easy. We just have 3 homework problems tonight. I do want to make a couple of brief announcements here at the very beginning. So the first one, obviously today we're working on some new content, which is the combined gas law. I did reschedule the exam. This is still tentative, but we're looking at somewhere around Tuesday, May 5th. There obviously was no way that we were going to be able to take the exam in 2 weeks. The next lab is actually our next class, which is a week from today on Tuesday, April 14th. And then tonight's homework again is problems 3, 7, and 8. Now, a reminder to all of you that have missing assignments. Today is it. The marking period ends today. I say today in quotes because I'm actually recording this on Monday, but the marking period ends today, Tuesday, April 7th. If you have any homework assignments, tests, quizzes, labs, etc., they must be turned in using the missing assignment drop box on Schoology. If you have any questions or any concerns about getting that done, you need to send me an email or shoot me a message through Schoology immediately. The grades are going out and any of those NHIs that are in there are going to become permanent. All right, hopefully that won't be a problem. If you don't have a chance to finish an entire assignment, I'll take whatever you have because some points are better than none. All right, we're going to move forward with our lesson today on combined gas laws. So if you look behind me, the combined gas law is exactly what it sounds like it would be. It is the combination of the 3 gas laws that we learned about on Friday of last week. So we have our P1V1 equals P2V2, our Boyle's law. We have our V1 over T1 equals V2 over T2, our Charles's law. And down here we have our P1 over T1 equals P2 over T2, which was Gay-Lussac's law. Now, if you look at the individual laws, something was being held constant. So temperature, volume, pressure. In the combined gas law, all 3 variables are changing. So nothing is held constant. All 3 variables are going to be different at the beginning than at the end. So we're going to try just one example problem today. That problem is going to combine a bunch of different things that we learned, so it's a really good practice problem. And then that's it. I'm going to stop after that today. So let's take a look at that first problem and only problem. Okay, so here is our example problem number 1. As we go through the problem, I'm going to write down the variables just like I encourage you to do, and then we'll talk about anything that's of importance as we go through this. So a gas has a volume of 800.0 milliliters. So my volume 1, that's for my gas, 800.0 milliliters. It is at a temperature of negative 23 degrees Celsius. Now, I'm going to write down temperature 1 as negative 23 degrees Celsius. But hopefully you remember that when we're talking about gases, we can never work with a temperature in degrees Celsius. So we're going to have to convert that temperature into Kelvin. The way that we do that is by adding 273.15. Notice 2 decimal places, 2 decimal places, so my answer is going to have 2 decimal places. So my answer in this case turns out to be 250.15 Kelvin. Notice that it's smaller. The reason why it's smaller than 273 is because we started with a negative temperature. So if 0 degrees is 273 Kelvin, then negative 23 degrees Celsius has to be a temperature that's less than 273 Kelvin. All right, let's keep reading. And a pressure of 300.0 torr. I'm going to end up changing that in a minute. What would be the Celsius temperature? So our unknown in this problem is temperature 2. So what is that? And just a reminder, we're going to have to convert that back to Celsius. So we're in Celsius. We have to convert it to Kelvin, complete the problem, convert it back to Celsius. What would be the Celsius temperature of the gas if the pressure were changed to 0.752 atm, 0.752 atm, and the volume of the vessel were cut in half? Well, the volume of the vessel was originally 800 milliliters, so the volume of the vessel down here is going to be 400.0 milliliters. I don't know if anyone can spot it, but we have a problem. And the problem is with the pressure. We cannot complete a problem where we have pressure in 2 different units. So what we're going to have to do is take our, and it doesn't matter which one you convert, but I typically convert to ATM. we're going to take our pressure that's in torr, and I'm going to convert that to ATM. And we went over this in the video last Tuesday. So if you didn't look at the video from March 31st, go back and look at that. It'll teach you how to do this. So we have 760 point torr is equal to 1 ATM. So that turns out to be a new pressure of 0.395 ATM. That is our pressure number 1. And now if you look, both pressure 1 and pressure 2 have the same unit. All right, let's take a look at our equation. So we have P1 V1 over T1 equals P2 V2 over T2. We're solving for T2. And that's a problem for some of us, because when I looked over the problems that you did last week, many of you did not bring the variable that you were solving for to the top of the fraction. So if you forget to do that, you're going to get a wrong answer because you're actually solving for 1 over temperature instead of solving for temperature. So before you do anything else, if your unknown, if your variable that you're trying to find is on the bottom, the very first thing that you need to do is move that to the top. That's the first and most important thing to do. Now, I'm going to get that variable, isolate that variable, get these other variables away from it. So I'm going to wind up with this equation. T2 is equal to, T1 is going to come up here, so it'll be P2 V2 T1. And then on the bottom, P1 and V1. P1 and V1 down here. What we're going to do now is we're going to take all these variables that we have numbers for, plug them into our equation. So we're going to get T2 is equal to P2, my P2 is 0.752 ATM. My V2 is 400.0 milliliters. And my temperature 1 is 250.15 Kelvin. I'm going to take all of that. I'm going to divide all of that by my P1 and my V1. So my P1 is 0.395 ATM. And my volume 1 is 800.0 milliliters. When you are typing this into the calculator, please remember to either hit divided by twice, so divided by before you enter in 0.395 and then divided by again 800, or put the entire bottom in parentheses. Either way, you're going to get the right answer, but you will most surely get the wrong answer if you forget to do at least one of those. The next thing, we are going to get an answer of 238 Kelvin. If you have an answer that is much larger, like millions larger, that means you forgot to divide by the 800. So the last part, because we're looking for a temperature that's in Celsius, we're going to take that number and we're going to now subtract 273.15. Notice we have 2 decimals here, but none here, so our answer won't have any decimals. So our temperature 238 is going to end up being negative 35 degrees Celsius. If you do the problems correct, notice how nicely all the units cross out. So ATM drops out, milliliters drops out. I'm left with Kelvin. I'm looking for an answer, initially at least, in Kelvin. The other part is based on significant figures. I was limited to 3 here because I had 3, 4, 5. So 3 is my minimum. I had 3 again here, so my answer could only have 3. That's multiplication and division. Then when I do the subtraction part, I have to look at decimal places. No decimal places, 2 decimal places. So my answer can have no decimal places. So I wind up with a temperature 2 of negative 35 degrees Celsius. Okay, I'm going to finish that for today. It looks like we're showing up just under 10 minutes here, which coincidentally happens to be about how long I can hold your attention span when watching a YouTube video. Yes, I can see that most of you are checking out somewhere around 10 minutes. Good luck to you, because we will eventually need to know the information in the entire video. So hopefully you can go back and check some of those out if you haven't done so already. Subscribe to me on YouTube if that works as well as a shortcut to find my videos. And hopefully I'll see see some of you tomorrow during one of two Zoom sessions, one at 10 a.m. and one at 12 p.m. I'll post the links for those on Schoology so you can click in. Hopefully we don't have the issues that we had late last week. If I don't see you, have a nice break.